Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today is Sunday and today is mock test day, and in today's test we have given you the chapters classification of elements and periodicity in properties and chemical bonding and molecular structure. So I hope all of you would have downloaded the question paper from our WhatsApp channel or from the community post, and you have already solved the question. So now it's time to check the solutions. So you need to see the video, check your solutions, score yourself and comment down your scores, okay, so that I can know how much you have prepared this chapter. Okay, so let us go with the first question here. So now if you see, the first ionization enthalpy of given elements is, okay, so now here we have lithium, beryllium, boron, carbon. Here you remember we have an exception between along the period it should increase, right? So beryllium should have less than boron, but boron is like beryllium is having 2s2 configuration, so that is why beryllium ionization energy is more, so correct answer is option number A. Next we have the property of halogens which is not correctly matched. So density, yes, it is matched, down the group density increases. Electron gain enthalpy here is your if you see chlorine and fluorine, chlorine electron gain enthalpy is more due to inter-electronic repulsions in fluorine, right? So that is why option number B is the correct answer. Now elements X, Y, Z have atomic number 19, 37 and 55. Which of the following statements is true about them? So X, Y and Z, right, they are belonging to the same group. This is potassium, rubidium and cesium, right? So now if you have Z would have the highest ionization potential, so down the group the ionization potential decreases, right? So that means Z should have the least one, so this is incorrect. Now Y would have the highest ionization potential, so Y is in between here, so it cannot have highest, so this is also incorrect. Their ionization potential would increase with the increase in atomic number. Ionization potential is decreasing, so that is why this is also incorrect. Y would have ionization potential between X and Z, yes, this is correct, so option number D is the correct answer. Next, amphoteric oxide is your beryllium oxide. Third ionization energy will be highest in alkali earth metals, because after removal of 2 electrons from magnesium, just imagine, after removal of 2 electrons we get a noble gas configuration, so to remove the third electron we will require more energy here. Next, the first ionization enthalpy of the following elements are in the order. So first ionization energy, so you have carbon, nitrogen and it is silicon and phosphorus, right? Down the group ionization energy decreases, so that is why this one will have less than this one. Along the period ionization energy again decreases, along the period it increases, so silicon will have the least one, so we can eliminate all these options. Correct answer will be option number D here. Next, which of the following is the correct order of radius? So you know, first anion, then neutral atom and then cation, right? So here you can see this is the order, so correct answer is option number A here. Next, which one of the following is amphoteric? Aluminium oxide. Then the electronegativities of carbon, nitrogen, silicon and phosphorus, the same thing. Down the group electronegativity decreases, so silicon will have least here, so we can have these two options, we can eliminate these two options. After silicon we will have phosphorus, right? After these two carbon will have least, then nitrogen, so option number A here. Next, if you see for one of the element, various successive ionization enthalpies are given below. Now here if you see, there is a highest gap between third and fourth. That means after the removal of 3 electrons we are getting noble gas configuration. That means it should have 3 electrons in the valence shell, and that is none other than your aluminium, right? Next, question number 11, again about the radius, so same thing, anion, neutral atom and then cation, right? Now if you see here, anion is in between, this is wrong, and here if you see, yeah, calcium 2 plus, K plus and S2 minus, this is correct. More is the cation, lesser is the size, so option number B is the correct answer here. Okay, next we have to tell the trends. For the properties mentioned, the correct order of the trend of different species. Okay, so here Lewis strength acid, that is correct. Boron, aluminium, gallium, this order is correct. Inert pair effect, aluminium does not show inert pair effect. Oxidizing property, order is also not correct. And if you see first ionization enthalpy, thallium has more first ionization enthalpy due to inert pair effect, so option number A is the correct answer here. Now the smallest anion here, smallest ion, so cation should have, so ion we can eliminate. More is the charge, smaller is the size, so option number C here. Next, which of the following has the positive electron affinity? So argon will have positive electron affinity because it is a noble gas. To add more electrons in argon, you will require more energy. The decreasing order of ionization potential of the following elements. Okay, this is important question here. So first let us note down the elements given. So we have neon, okay, we have chlorine, then you have phosphorus. Okay, so we have phosphorus, then we have sulfur, okay, then we have aluminium and magnesium. Okay, now if you see, this is a noble gas, so its electronic configuration will be highest, and ionization potential along the period it increases, so this side it will decrease, right? So that means chlorine should have the next ionization potential, that is all were present. Now if you compare phosphorus and sulfur, right, so phosphorus will have more than sulfur. Why? Because phosphorus has what I can say is having a half filled configuration, so that is why phosphorus will come, then sulfur will come, so we can eliminate these two options. And now if you compare aluminium and magnesium, right, the same thing of boron and beryllium, right, beryllium will have more because we have to remove electron from 2s orbital here, and here it will be from 3s, here you will remove from 3p, so that is why magnesium will have more than aluminium, so option number B here. Next, question number 16, which of the following statement is incorrect? It's about bond length. So if you remember, bond order of O2 plus will be less than the bond order of O2 2 minus. This statement is wrong. Now how to calculate bond order, I already told you. You can just remember 14, 15, 16, 17, 18, then 13, 12, 11 and 10. 1, 1.5, 2, 2.5 and then 3, 2.5, then 2 and then 2, 1.5 and then 1. Now if you see O2 2 plus is having 14 electrons, right? So O2 2 plus 14 electrons has 3 bond, then we have O2 16 will have again 2, and then you have O2 minus, okay, so that is 8 plus 8 16, 8 plus 8 16, 17, 18. So here the bond order is 1. So what is the order of bond order? Bond order will be O2 2 plus, then you have O2 and then you have O2 2 minus. What is bond length order then? It is O2 2 minus, O2 and O2 2 plus, right? So now if we see the first one, bond length of O2 is greater than O2 2 plus, this is correct statement. Bond order of O2 2 plus, okay, is less than the bond order of O2 2 minus. This is incorrect statement, that is option number B is the correct answer here. Next, in oxygen and carbon, that one, so in oxygen there is 1 sigma 1 pi, carbon also 1 sigma 1 pi, correct answer is option number C. Next, incorrect statement about hydrogen bonding, this is correct. Dispersion force, sigma bonds are stronger, this is correct. Ionic bond is non-directional, this is also correct. Sigma electrons are less, are mobile, this is wrong. Pi electrons are mobile, so correct answer is option number D. Next, the boiling point, if you know, water has more boiling point because of hydrogen bonding, so option number B here. Formal charge on ozone, so if you just calculate the structure of ozone, it is like this, okay. We have to calculate the formal charge of this oxygen, so total valence electron is 6, non-bonding electron is 2, and then 1, 2, 3, 4, 5, 6 by 2. So we will get plus 1, so correct answer is option number C. The percentage of S character in the hybrid orbitals of nitrogen is given. So first if you calculate NO2 plus, okay, so how many electrons are there? 5, 6 plus 6, 12 minus 1. So 17 minus 1, 16 electrons are there. Now if you see 16 electrons I want to arrange, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and so I have arranged 16 electrons, but if you see here the nitrogen octet is not satisfied, right? So what I can do here is I will write like this, okay. Now if I see the octet is satisfied and nitrogen has 2 sigma bonds, so hybridization will be sp. If hybridization is sp, then 50% s and 50% p, so that is why correct answer will be option number B. Thus you can check the hybridization, this will be sp2 and this will be sp3. Next, question number 22, bond angle in pH4 plus is more than that of pH3. This is because, so in pH4 plus what happens, there is no lone pair, right? It is a tetrahedral structure, and in pH3 there is a lone pair. So lone pair bond pair repulsion takes place. So that is why the pH3 bond angle is less. Okay. Which of the following poses a net dipole moment? So SO2 will have net dipole moment. Here it is sp2 geometry, right? Trigonal planar. So bond angle net dipole moment is 0. This is sp hybridization, linear, again net dipole moment is 0. This is sp and this is also linear and the net dipole moment is 0. So option number A is the correct answer. It has sp3 hybridization and it is a bent molecule. Next, which one of the following contains two lone pairs of electrons on the central atom? So if you see NF3 has one, NH3 has one, we can eliminate this one. SO4 has no lone pair, eliminate this one. So option number A is the correct answer. Intermolecular hydrogen bonding is present in para-nitrophenol. In ortho-nitrophenol you will get intramolecular hydrogen bonding. Okay. Next, the state of hybridization. So in carbon dioxide the molecule is like this. We have 2 sigma bonds, so it is sp hybridization. CH4, okay, tetrahedral 4 sigma bond, so it is sp3. CO3 2 minus is, we have 3 sigma bonds, so it is sp2. Okay, correct answer is option number C here. Next, which of the following structures of a molecule is expected to have 3 bond pairs and lone pair of electrons? So if you have 3 bond pairs and 1 lone pair, okay, then that is called as pyramidal structure. So that is your option number D here. Next, which of the following is the correct electron dot structure of N2O molecule? Correct electronic dot structure. So for correct electronic dot structure, the basic rule is octet should be satisfied. Here you see octet is not satisfied, octet is not satisfied, eliminate these 2 options. Here octet is satisfied, here also octet is satisfied, then how can we decide? We need to check the formal charge. Okay. So now if I draw the first compound, that is you have N, double bond N, okay, then you have double bond oxygen and you have 1, 2 and 1 and 2, right? Now if I see here formal charge, if I want to calculate N1 and N2, okay, N1 will have 5, okay, minus 4, then I have 4 minus 2, okay, so this will give me minus 1 charge. Okay. Next, nitrogen if I calculate, so there is 5, then here we have no, then we have 1 2 3 4 5 6 7 8 by 2, that is plus 1. So this charge is plus 1. Then oxygen is having 6 minus 4 minus, we have 2 minus 2, right? Once again, sorry, 4 minus 2, 4 by 2. So this one will give me 0 charge. So we have 0 charge on oxygen. Now same thing if I calculate for this one, N, triple bond N, O, 1 2 3 4 5 6 and N. So this nitrogen will have 5 minus 2 minus 6 by 2, okay. So this one will give me 0 charge. Next, this N is having again 5, no unpaired electron, then 1 2 3 4 5 6 7 8 by 2. So that will be 8 by 2 is 4, so this is plus 1, okay. And then we have oxygen, and oxygen will give you 6, and non-bonding electrons is also 6, 2 by 2, and that is giving you minus 1, right. So the charge here is minus 1. Now if you see the structure, both the structures here, the negative charge on oxygen is more stable than the negative charge on the nitrogen. Why? Because of more electronegative nature. Okay, so that is why the correct answer of this question will be option number D. Okay, negative charge on this compound will be more stable. Next we'll go for this one, bond order. So again we can calculate 8 plus, so O2 is having 16, bond order is 2, O2 plus 15, right, so its bond order is 1.5, O2 minus, right, 17 means it will have also okay, 1 second, let me write down, 14, 13, 12, 11, 15, 16, 17, 18, and then here I have 1, 1.5, 2, 2.5, 3, 2.5, 2, 1.5 and 1. Okay. So now if I see O2 minus, 17 will have 1.5 and O2 plus means 16, 15 will have 2.5, sorry, yes. Next we have O2 2 minus, so 16, 17, 18 will have 1. Okay. So now if I order this one, so first I will get O2 plus, okay, then I will get O2, then I will get O2 minus, then I'll get O22 minus. So option number B is the correct answer here. Next, HCl gas is covalent and NaCl is ionic compound. This is because, so you know that for ionic bond we need a electronegativity difference of 2.1 or more. So that is why between hydrogen and chlorine the electronegativity difference is 2.1, less than 2.1. So correct answer is option number D. Okay. So yes students, these were the questions for your KPL 12, and I hope all of you have solved the questions. Do not forget to comment down your scores, and if you have any doubt in any question, that also you can ask in the comment section. I'll definitely address it. Okay, so thank you for watching and stay tuned for day class, next class, and do not forget to subscribe the channel.